What's up guys, welcome back to the channel. In this particular video I will explain the problem level of nodes. Guys, from some time I was unable to upload the video due to some technical reasons, but now I am again continuing this series on Geeks for Geeks problem of the day. Starting with the problem statement, so it says that you are given an integer x and an undirected acyclic graph with v nodes and e edges, and nodes are basically labeled from 0 to v minus 1. Our task is to look for the level of node which is labeled as x, right? So our task is to find the level of node x. Now level is basically defined as the minimum number of edges that you must travel from 0 to some target. Okay, let me explain this guys. So I'm going to take this particular graph. So see guys, for this graph, all the nodes which are at one edge distance basically says that I have one edge here, right? So all these nodes which is 1 and 2 are basically at level 1 because these are at one edge distance. After this, all these nodes are at 2 edge distance, right? So 3, 4 and 5, the level is going to be 2 for these nodes. So basically the minimum number of edges is going to tell us the level of any node, right? So see, one line is also written here. If there is no any node which is labeled as x, then you can simply return -1 because for that node there will not be any existing level, right? So guys, one example is written here, and for this example you can see that the value of x is equal to 4. So also I have already defined that how we can calculate the level. So you can see that the node 4 is at level 2, right? So guys, 2 is going to be the output for this particular example. Now I hope problem statement is clear to you. So let's talk about the solution now. Okay, so guys, first of all, let me write the same example which is given to us here, right? So that I can get some space. So we are given a tree-like graph. I'm saying tree-like because the graph is basically undirected graph and acyclic graph, right? So this is the structure that we have, and talking about the nodes, so nodes are labeled as 0, then 1, 2, then I have 3, 4 and 5. The approach basically says that we can traverse this particular graph level by level. So first of all, I will traverse this particular level, and along with traversing I will also check if my current node is equal to the given node which is 4 for this particular example, right? So we have to look for the node x equals to 4. And now see one thing, what I'll do is I'll first traverse this level, then I will come to this level, and I want level count as well. So initially the level count is equal to 0, and the moment I move from one level to another, I'm basically going to increase the level count, right? So now level count will become 1. After this I will go to this level and level count will become 2 now. And see guys, for level count equals to 2, you can see that I have found the node which we want, like the value of x, right? I have found the value of x, so I'm simply going to return the current level count, and this way I will get 2 as the output. So this is the approach that we have, and the question is how to implement this. We are programmers, right? We have to implement the solution in terms of code so that computer can understand it. So what we are going to do is, first of all, we need a data structure in order to store this particular node. So first of all, I'm simply going to store 0 in a data structure. So what I'll do is I'll now traverse this particular data structure. So let's say this data structure is ds, right? So I'll say that okay, while my ds is not empty, not empty, right? Let me write something like this, because this is a pseudocode, so I don't care about the function name, right? So while my ds is not empty, so what I can do is I can basically traverse this particular node, right? So this node is nothing but the first level that we have. So guys, whenever we have a level, we are going to traverse that particular level in one go, right? So for this particular node, what I'll do is I'll basically, first of all, I'll get the size. So I'll say that okay, size equal to ds dot size, right? I'll get the size of data structure. After this, I will traverse every node in this particular data structure. So for now we have only one node, so I'll say that okay, for I equals to 0, then I smaller than s, then I plus plus, right? This is the loop that we have. Inside this loop I want to get every node, so I'll say that okay, node is basically equal to ds dot, I'll say get, right? I'll say get node. And now what this will do is this will basically give me the node which I have inserted into this particular data structure, right? And guys, once I have got this particular node, so I will check if my node is equal to the target node that we want to find. If this is the case, then I can simply return level count, right? I can return level. This is what I can do, and initially the level is equal to null. level is equal to 0, I'll say, right? And now you can see that even it makes sense, because if 0 is the target node and I have found 0, so I can simply return 0th level, because this is the 0th level, right? So guys, this is how it is going to work. And once I'm done with this particular node, so I'll store every neighbor of this node in the data structure, right? So I'll say that, okay, for every every neighbor neighbor okay, for every neighbor in, guys, for now just ignore the spelling mistakes that I'm doing, right? So for every neighbor of node, right, of node, I can simply insert those particular neighbor. So I'll simply do n dot insert. Okay, I have to do data structure dot add and that particular neighbor, right? This is what I can do, guys. And what this will do is, this will basically add, now 0 is not no more in this particular data structure, right? But I will add the neighbors of 0. So now I have 1 and 2 in the data structure. And now interestingly, see one thing here, guys. First of all, I have added 0 and this is the level 0 that I am storing, and now I am storing the level 1, right? And again, if I perform the same process, then first of all I'll go with 1 and I'll store the neighbor of 1, I'll have 3 4, and then I'll store the neighbor of 2, so I'll have 5 as well. And now this is storing the level 2, right? So guys, this is how this particular approach is going to work. And interestingly, see one thing here, we are getting only that particular element first which I'm inserting first, right? So this is first in first out. Is there any data structure that follows this particular rule? So yes, we have. Q is basically that data structure that follows this particular rule, right? So guys, what we can do is we can simply use a Q in place of this particular data structure and our task is done. So now I can replace this particular function by poll, right? I can do poll each time, and I can also do q dot add. This is going to work, and this is the whole approach that we have. At last, if we are not able to find any particular node which is equal to x, then I can simply return -1. This, because this is what the problem want us to do, right? Now guys, see, let's say we have a case like, I have a node here or I have any node, right? So guys, you can see that I have to avoid visiting the same nodes again, right? So what I can do is I can basically write a visited array as well, so that I can keep track of visited node as well, right? So I'll make a visited array. This is of size v, and I'll basically visit every node. So I'll say that visited of n equals to true. This is simply going to visit this particular node, and after this I will check if my visited of neighbor is equal to false. Only that particular case I will visit this particular neighbor, right? So guys, this is the whole approach. Very simple, very straightforward. All we need to do is you just need to perform level order traversal, right? Now let me show you the code quickly. So here I am storing the code, guys. You can see that this is the C++ code that we have. After this we have the Java code as well. So in C++ we are, you can see that we are using the visited array as a vector of boolean type, and q as an integer. Why integer? Because we have integer type nodes, right? And apart from this, it is using linked list, like this is basically adjacency list representation for a graph, right? Apart from this, guys, this is the Java code, and you can see that in Java we are basically going to implement an interface which is linked list, right? Apart from this, this is basically the Python code. So now I hope everything related to this particular problem is clear to you. Now let me talk about the time complexity, right? So the time complexity is basically O of V, right? Because we are going to traverse each particular node in this particular graph, right? Or I will say O of V plus E. Why? Because guys, this is something which is BFS or level order traversal. So this is also going to traverse each particular edge as well, right? This is about time complexity, and space complexity is nothing but O of V, because we are not going to use more than O of V space, right? V is basically the number of node which is given to us, and E is basically the number of edges, right? So now I hope everything related to this particular problem is clear to you. This is all about this video. Thank you.